Unlock the potential of artificial intelligence. Welcome to Deep Learning and Generative AI.
You know, every single day it feels like there's some new AI breakthrough, right? Something that's going to change, well, everything. But let's be honest, how often do we really pop the hood and see what's going on inside? Well, that's exactly what we're going to do today. We're going to go way beyond the headlines and learn how to become real investigators of the tech that's literally reshaping our world.
And really, it all boils down to this one big question. I mean, we all know AI is this massive, powerful force. But here's the thing. Its path isn't set in stone. It's not inevitable. It's shaped by the problems we decide to throw at it, the data we feed it, and maybe most importantly, the questions we choose to ask. Or, maybe more scarily, the questions we forget to ask.
And look, this is not just some abstract philosophical debate, not at all. These systems are out there, right now, making decisions with incredibly high stakes. Think about it. In criminal justice, you've got these risk-scoring tools that can end up baking in existing biases. Or in healthcare, where a system might use cost as a stand-in for health, accidentally creating huge racial disparities. And what about hiring? We've seen algorithms learn from our own messy history and just amplify gender bias. The bottom line here, and this is so important, is that you can't just critique the algorithm. You have to critique the entire system it lives in.
So, okay, what's the solution? What can we actually do? Well, it's about adopting a totally new way of thinking. Let's call it the auditor's mindset. This is all about making a shift, moving from just passively scrolling through headlines or reading research papers to becoming an active, critical investigator. Someone who knows exactly how to poke and prod at these systems to find the weak spots and the hidden assumptions.
And this really nails the shift we're talking about. The old way was kind of like being in school, right? You memorize the math, you see a high score on some benchmark test, and you just assume, great, it's ready for the real world. But the new way, the auditor's way, is so different. It's about questioning the entire context. It's about looking at those slick, pretty explanations and treating them not as the gospel truth, but as a hypothesis that needs to be tested. And, probably the most crucial question of all, always asking, who pays the price when this thing gets it wrong?
Okay, so having the right mindset is great, but a mindset isn't much use without a method, right? You need a game plan. To be a good investigator, you need a workflow. So, let's talk about the auditor's #1 tool, the 3-pass method. This is going to give us a really solid, structured way to break down pretty much any research paper that comes across our desk.
And honestly, the process is beautiful in its simplicity. So pass 1 is just the gist, a quick scan. You read the abstract, you read the conclusion, and you ask a simple question. Does the big claim at the beginning even match what they found at the end? You'd be surprised how often they don't. Then, pass 2. You're looking at the structure. Check out the diagrams, the tables, and try to pull out the main assumptions. And ask yourself, hey, wait a minute. Could a way simpler model get these same results? And finally, pass 3. This is the deep dive. This is where you roll up your sleeves and get into the nitty-gritty. You're checking the math, looking at the code, digging into those specific settings, the hyperparameters, and asking the million-dollar question. Can anyone else actually replicate this?
All right, so we've got our 3-pass method ready to go. Now it's time to load up our investigator's toolkit. Let's get into the specifics, the red flags you absolutely have to be looking for when you're doing an audit.
So the very first place you should look for trouble is right at the beginning. How do they even frame the problem? Are they optimizing for what really matters or for a proxy target? You know, like we talked about, measuring healthcare cost instead of actual patient health. And the data, is it actually representative of the real world, or is there a huge sampling bias where it's just full of data from one specific group? Oh, and be super skeptical of any paper that claims to be the first ever to do something, but they did it on private data that nobody else can see. How can you verify that?
Yeah, this here is a classic trap in experiments. The new model looks incredible, right? But take a look at what it's being compared to. Is that baseline a real contender, or is it a straw man? Basically, an intentionally weak opponent set up just to make the new model look like a superstar. Did they even tune the baseline properly? And you have to wonder, are they showing you the average result, or did they cherry-pick the one perfect run that looked amazing? Also, watch out for metric gaming. That's where a great overall score totally hides the fact that the model is failing miserably for certain important groups. And if you can't find the recipe, the actual training details, that is a massive red flag for reproducibility.
Okay, now we're getting into one of the trickiest topics out there, fairness. And here's the key thing to get your head around. Fairness isn't just one number you can push higher and higher. It's almost always a series of really tough trade-offs.
For instance, you can make a model have the exact same error rate for two different groups, but if those groups are different sizes to begin with, the outcomes could still be wildly unfair. So a good auditor doesn't just ask, is it fair? That's too simple. The real question is, for the specific definition of fairness they picked, who ends up bearing the cost?
You got to be so careful with the pretty pictures. I mean, look at these saliency maps, these heat maps that claim to show you where a model is looking. They look so convincing, don't they? But here's the kicker. Researchers have shown you can completely change these maps without changing the model's final answer at all. So here's the takeaway, and please remember this. Attention is not the same thing as explanation. These visuals aren't proof of anything. They're just hypotheses, and they need to be tested like any other claim.
And we have to talk about cost. And I don't just mean dollars and cents, I mean carbon. These huge models have a very real environmental footprint, and that has equity implications too. A proper audit demands that researchers report the CO2 equivalent, the training time, the whole shebang. And more than that, it demands they justify it. Is that teeny tiny 1% accuracy boost really worth a massive carbon footprint? Efficiency isn't just a nice-to-have anymore. It is a core part of the science itself.
Okay, so theory is one thing, but let's see how this stuff actually works in the wild. We're about to apply our brand new Auditor's Toolkit to some of the biggest, most famous papers in the history of machine learning. It's time to open up the case files.
So here's our lineup. We're starting back in 2012 with AlexNet. This is the paper that really kicked off the whole deep learning revolution. Then we'll jump to 2015 and ResNet, which let us build much, much deeper networks. After that, the big one, 2017's Attention is All You Need, the paper that gave us transformers. And to wrap it up, we'll look at a different kind of landmark paper from 2018, the audit itself, Gender Shades.
All right, first up on the docket, AlexNet. And you can't deny its strengths. This thing was a monster engineering achievement. It basically proved that training deep networks on GPUs was possible. But when we look at it through our modern audit lens, we see some huge gaps. The evaluation was 100% focused on the benchmark score. There was zero discussion of fairness or, the potential for surveillance. So the verdict? It's foundational, for sure. But man, does it show how far the standards for responsible AI have come.
Next case, the ResNet. And again, technically brilliant. The mechanism was clear, the evidence was strong and reproducible, all good stuff. But the critique is just as obvious. It has a bad case of metric myopia. Success was only defined by that single aggregate accuracy number. It was completely blind to what might happen when you take it out of the lab and the data shifts, like it always does in the real world. Our verdict? Amazing technology that absolutely positively needs external governance when you apply it to people.
And now for the paper that really started this whole generative AI explosion we're living through. Attention is All You Need was a genuine paradigm shift, no question. But the audit is pretty damning. The evaluation was laser-focused on just one task, translation. The risks of safety and misuse? Completely unexplored. And the compute cost? It hinted at a colossal environmental footprint. Look, a paper with this much impact needs way more than just a publication. It needs a full-on system card that lays out all its risks.
And then, in complete contrast, we have Gender Shades. This paper is the audit. This is the investigation that discovered that these commercial facial recognition systems, the ones bragging about over 90% accuracy, had absolutely shocking error rates when looking at darker-skinned women. This paper proved, beyond a shadow of a doubt, that overall accuracy can be incredibly dangerous and misleading. It basically established the audit as a crucial form of research. It really is the gold standard.
So we've reviewed the evidence, we've learned the techniques of the trade. What's the final verdict? What are the big takeaways from our whole investigation here? Okay, here it is, your own personal cheat sheet for your investigations. You gotta remember these 5 red flags. First, overclaiming. That's when someone takes a result from one little benchmark and acts like it applies to the whole world. Next, leakage. These are just basic, sloppy data hygiene mistakes. Then, no stats. Claiming something is better without any statistical proof. Silence, a complete black hole where the discussion on ethics and misuse should be. And finally, the saliency trap. Just because the heat map is pretty doesn't mean it's reasoning.
Ultimately, this is the big picture. Responsible machine learning isn't some checkbox you tick off at the very end. It's a continuous, ongoing discipline. And trustworthy research? It's built on these 3 pillars of transparency. You need model cards to document the model's limits. You need data sheets to show where the data came from. And you need full reproducibility. Give us the code, give us the data.
And I just want to leave you with this one final thought. Think of it as a mantra for the modern AI auditor. The next time you see some big, flashy claim, don't go looking for some single capital T truth. That's not the goal. Instead, look for the details. Look for the actual evidence they're providing to back up their claims. Look for the trade-offs they definitely had to make, and look for the boundaries, the places where this thing just completely falls apart. Because that is how we move beyond the abstract headlines. And honestly, it's how every single one of us can play a part in building a better and way more accountable future for this technology.